Alright, welcome to example 3. Again, we're just going to continue on double integrals, and in this case we have a double integral xy squared. Good thing about this is we're not having to do this in both directions, and it's enclosed by x equals 0 and x equals square root of 1 minus x squared. Again, we can set both of these equal to one another, but hopefully you're seeing, oh, hey, this is going to be using a semicircle due to, our equation over here. But again, if you want to set them equal to each other, you can. You're going to get the square root of 1 minus y squared equals 0, square both sides, and then y squared equals... you're just going to bring the y squared over equal to 1. So y is equal to plus or minus 1. So let's go ahead and we can plug in. So for y, I'm just going to go from negative 1 to positive 1. For x, it's x equals 0. And it's going to go all the way to, when I plug in positive 1, I'm going to get 1, I'm going to get 0. And then when I plug in negative 1, I'm going to get 0, but because this is a equation of a circle, then it tells me that the furthest I'm going to go right is going to be a radius of 1. So 1. And so now I'm going to go ahead and graph. So I have a region from 0, and then I am doing a circle. So there's my circle. All right. So we have everything that we need, but it looks like for this one, I can't really do top bottom. I'm going to have to go from left to right. And so what I'm going to do is first define my y's. And so this is going to be a type 2. So I'm going to go from y equals negative 1 to y equals 1. And then I'm going to go from the integral 0, x equals 0, and x equals square root of 1 minus y squared. So here's the function xy squared, and then dx dy. So now let's go ahead and integrate this. Again, first thing you need to do is draw your region. Once you draw your region, it's going to make, finding this a little bit easier. All right. Don't like it when it's two colors. All right. And I forgot to highlight the answer here, so let me do that real quick. All right, so let's go ahead and integrate with respect to x. And so when I do that, I'm going to get 1/2 x squared y squared, and I'm going to go ahead and plug in a bound 0, 1 minus y squared. And I'm going to have dy on the outside. So let's go ahead and do that. All right, we'll plug in. We're going to get 1/2 x squared times 1 minus y squared. So for the first part, we're going to get negative 1 to 1. We're going to plug that in. We're going to get 1/2 x. I'm plugging that in. So we're going to get 1/2 y squared. All right, a minus y squared. So minus 1/2 y to the 4th. And then we're going to plug in, looks like 0. So we're just going to be left with, when we plug in 0, it's going to eliminate everything. And so we're just left with dy. I'm going to go ahead and rewrite this. I can pull out a y squared. And so that's what I'm going to do. I'm going to go ahead and pull out a y squared, and no, I'm not going to do that. I'm just going to go ahead and pull out a 1/2, and so I'm going to have 1/2 the integral of negative 1 to 1 y squared minus y to the 4th dy. And now let's go ahead and integrate that. And when we integrate that, it's not too challenging. we're just going to have 1/2 on the outside. And we'll have 1/3 y cubed minus 1/5 y to the 5th. Plug in 1 and -1. And when we plug that in, we're just going to get 1/2. We'll have 1/3 minus 1/5 minus 1/3 minus 1/5. And so the 1/3 will cancel out, but 1/5, no, I'm sorry, I'll plug it in. This should be negatives. And that will double it, and I should have realized it will double it. And so then when we do that, we're just going to get 2/15 when we add all those together. All right, and that's it. Trying to figure out what was needed to do, and that was highlight the answer. All right, so now here we're just going to give a situation underneath the surface. So it gives us our function. It gives us our z, which is 1 plus x squared y squared. So there's our surface. And above the region enclosed by, so x equals y squared, x equals 4. All right, so let's go ahead and sketch that region. X equals y squared and x equals 4. I'll find the values first. So again, y squared equals 4, so y equals plus or minus 2. It gives me an idea of how to draw this. So it looks like I'm going to go from -2 to +2. And if I plug those values in, it looks like x is going all the way to 4 for both of those. And x equals y squared is going to be a sideways parabola. And so those are our intersections. And so it looks something like this, where that's x equals y squared, and that is going to be y. No, sorry, that's x equals 4. All right, so what we can do is we go ahead, and since these are both already in terms of x, let's go ahead and put our y's on the outside. All right, and so what color do I want? Let's use this. It doesn't matter. All right, so -2 to 2. And then for our x's, we're doing a left-right approach. And so far right is going to be 4. Far left is going to be y squared. So 4 y squared. And our function, our surface is 1 plus x squared y squared. And this is going to be, these are y equals x equals, so dx dy. I forgot to put x equals 2, x equals 4, and make sure I denote that that looks like a 4, because that doesn't look like a 4. All right, so now let's go ahead and integrate with respect to x first. So -2 to 2, and we're just going to get x plus 1/3 x cubed y squared. And we have dx dy. So we are going to have dy, because we're integrate this with respect to x, so y squared 4. Substitute those values in. So -2 to 2. And it looks like we're going to get 4 plus 4 cubed, 64 over 3, 64 over 3, y squared, minus, plug in our y squareds, we're going to get y squared plus 1/3. Looks like y squared cubed is going to be y to the 6th, so y to the 8th. dy. Let's go ahead and clean that up. So we do have two y squared, so we go ahead and add and subtract those. We're going to get 4 plus 61 over 3 y squared minus 1/3 y to the 8th dy. And let's go ahead and integrate with respect to y. So we get 4y plus 61 over y to the 9th. I'm doing too much, too fast. So over 9. Y cubed minus, that's going to be y to the 9th. So 9 times 3, so 1 over 27. I'm going to plug into -2. And I'm just going to skip to save some time. We plug these in, and we'll get 2,336 over 27. Just to save some time on